This tutorial covers some important topics in structural geology. In this first part, we will cover some definitions about how to define the orientation of subsurface geological layers or structures and how this is represented on maps. The first thing to discuss is compass directions. We use compass directions to define the orientation of planar surfaces, so we need to understand how these are defined. Direction is defined by the points of the compass. There are 360 degrees of orientation, with north being 000 degrees, east being 090 degrees, south being 180 degrees, and west being 270 degrees. Any direction can be defined by a measurement of degrees from north using a compass. Degrees are always written in 3 figures. Now we can talk about defining the orientation of surfaces in geology. These surfaces could be bedding planes, or faults, or other planar features. It is important to know what orientation these features are in the subsurface so we can predict their location in our fields. Our notation of this orientation needs to follow a standard so that others can recognize the records that we make. Mathematically, any plane can be defined by 3 points and any line by 2. What we do in geology is define the orientation of a horizontal line on the geological surface, called the strike, and then the angle that the plane is dipping away from that horizontal line, called the dip. This gives us the necessary unique points to define the orientation of the plane. How then do we measure strike and dip? We use a compass to measure the orientation of our horizontal line. Geological compasses have a level bubble installed on the compass surface, so that when we hold the compass hard against the geological surface and make sure that the bubble indicates level, we are creating a horizontal plane in our compass, and the intersection of our horizontal compass and the surface makes a horizontal line on the surface, which is the strike. We can then use the compass to measure the orientation of this line. Dip is always at a maximum 90 degrees around from the strike, and we can measure the angle of dip, which is down from a horizontal plane, using a clinometer. Geological compasses often have a clinometer included within the instrument for this purpose. We write this down by writing the strike as a 3-digit number, a slash, and the dip angle. To be absolutely clear, we also need to provide the direction of dip, as simply strike and dip noted could be dipping to one side or the other. There are a number of standard rules that people apply. You may encounter the left hand or the right hand rules, which specify which strike value you give for a specific orientation of dip, but since these are sometimes inconsistently applied, it is easier to simply give the direction of dip as an extra piece of information. How do we indicate the orientation of geological units on a map? In the simplest case, we use a strike and dip symbol, which consists of a long line indicating the strike orientation and a short line indicating the direction of dip, with a number to give the angle of dip. In the case of subsurface rock units, we can contour the surface of the rock in depth in the same way that we can contour the surface of the earth in height. Contours on the surface of a rock unit are called structure contours, as they are contours that delineate a geological structure in the broadest sense of the word structure. This block, for instance, shows a simple case of structural contours, how they can be defined on a dipping bed and then projected into a map view on the surface. We will spend a lot of time while mapping thinking about the shapes of structure contours as used to identify structures in the subsurface. I hope this tutorial has helped you to understand better some of the topics covered in structural geology. Do continue on to watch the second and third part on faults and folds. For more information, see the notes and the PowerPoint slides, and in order to test your understanding, make sure to do the tests available in Vision.